Hello once again, Algebra 2 people. Welcome to section 4.3, which is all about division. So we're going to kind of go back to 4th grade and do a little long division, except that we're going to do it with polynomials. So this is going to be an interesting exercise. We're going to do it two different ways. So we're going to do long division. And then I'm going to show you a beautiful shortcut, which I recommend you do most of the time. But just to kind of refresh your mind on long division, so when you see something, a polynomial divided by another polynomial, it means that we are going to take our divisor. It goes on the outside. Here's your long division symbol. And we write the numerator underneath, making sure that all powers of x are being represented. Otherwise, we'd put in a placeholder. And then the dumb monkey sometimes burp. This was an acronym that I got from my daughter to help remember the process you're going to go through. So you're always focusing on just the first term when you start off. And you're doing the D represents divide. So I'm taking x squared and I'm dividing it by x. And so you're taking the x squared divided by x, and the answer would be x. So where do you put your answer? It goes on top. Then the next step is to multiply what you got, which was the x, by the original x minus 5. And what is that? That's going to give us x squared, because you set it up that way, minus 5x. So that's the multiplication. Then what you always do is you then subtract. But with these problems, rather than subtract, what I would do is S should be change the signs. Because when you subtract now, you have two terms. So that means this becomes subtraction, this will become addition, because you're going to distribute that negative. So what do we get? Well, you should always have that first term cancel out because you've made it that way. 3x plus 5x is 8x. And then the B represents bring down. So we are going to bring down the minus 9, and we start the process all over again. So you look at just the first terms, and we divide. So I'm going to divide 8x divided by x. That would give me 8, a positive 8. So I put the answer up here, plus 8. Then we do our multiplication. So it's going to be 8. It's always going to be multiplying this by your original divisor. And the answer goes down here, 8x minus 40. Now we do our change signs. All right, so our addition will go to negative and negative goes to positive. So this becomes negative, that becomes positive. So 8x minus 8x goes away as it should, and 40 take away 9 is going to give me a positive 31. That back in 4th grade, you could just call your remainder, but now that is a remainder out of something. So we write it's a plus, because that's a positive 31, over our original divisor. And that's what your answer would be. So putting it all together, x plus 8 plus 31 over x minus 5. That is how your final answer will look. So the remainder goes over your original divisor. All right, so you're doing long division. Here's another example. Now, we just learned how to factor the sum of two cubes or the difference of two cubes. And what I like about this is if you forget how to factor, you can always figure out the answer by long division or synthetic, as you'll see in a minute. But let's practice the long division one more time. So this means that x plus 4 is going to go on the outside. On the inside, we have x cubed. Notice there's no x squared, so I have to put a 0 there. I also have no x, so I have to put a placeholder there. But then we do have the plus 64, so that comes off here at the end. So let's see how this plays out. remember we start off with divide the first terms. So that's x cubed divided by x, which gives me x squared. Then we multiply, so this x squared gets multiplied by x plus 4, and the answer goes underneath here. So x cubed plus 4x squared. Now you can see why we needed that placeholder, because we are going to be subtracting like terms. So remember, this means change signs. So this becomes negative, and this will become negative. So those first terms cancel, and I'm left with just negative 4x squared. And I bring down my 0x. So that was my bring down. And we start the process all over again. So I'm dividing my first terms. So notice now I have a negative 4x squared divided by x. That's going to give me a negative 4x. The answer will go up here on top, so minus 4x. So we can now multiply negative 4x times x plus 4. That'll always give you the same initial term if you do it right, negative 4x squared, and then minus 16x. So now we want to change our signs. So that means this is going to go positive, this is going to go positive. So the first terms go away. And I have a positive 16x, and I bring down my 64. And I'm going to go one more time. So we are dividing the first term by x. So I'll just kind of, since we had to do it again, dumb monkeys sometimes burp. So we're dividing 16x divided by x is 16. So this becomes a plus 16. And then we multiply 16 times x plus 4, which gives us 16x plus 64, which means we have no remainder. So what does this all mean? That means that when you take x cubed plus 64 and divide it by x plus 4, the answer was x squared minus 4x plus 16. Remember, if I were to cross multiply, that means that this times this equals the sum of the cubes, which is how we factor them. So if you forget how to factor your sum of cubes or your difference of cubes, you can always do the long division. But long division takes up a lot of space. It's kind of cumbersome. So in the next slide, I'm going to show you a much nicer way to do this. Okay, so now we're going to give you a new sort of algorithm for doing division called synthetic division. That does not take up a lot of space. It's kind of a shortcut, so we're not going to deal with any powers of x. We're only going to deal with the numbers. So what we're going to do is we have a polynomial divided by another polynomial, trinomial divided by a binomial here, and we are going to use synthetic division. So what we want to do is take our divisor, which is really taking the root or the x-intercept or the solution of x minus 8. That would be a positive 8, so it's just the r. Okay, so if I set x minus 8 equal to 0, the answer would be 8. That 8 is going to sit here, so positive 8 in a little box. And I'm going to draw a line here, put a little plus here. What is going to go next to the 8 are the coefficients of what I'm dividing into, again keeping track of whether I need any placeholders. In this case, I don't. So the coefficient on x squared is just a 1, on the negative 5x, and then negative 24. All right, so that's the setup. So you have the little divisor sitting in a box, and then you just have the numbers, the coefficients of your numerator. To start the process, you always drop that initial coefficient. So that goes down. And now the process is going to be multiply, add, multiply, add. You're always going to be multiplying against this 8 that's in the box. So 8 times 1 is 8. And the answer goes, so what we did was 8 times 1, we multiplied, put our answer here, and then I add going down. So 8 minus 5 is 3. And now we repeat the process. 8 times 3 is 24. So we multiply it always against the box. 8 times 3 was 24. Answer goes over here. We add, and we got a 0. That means we have no remainder. Now you might say, well, what does that 1 and 3 represent? It's what we call a depressed polynomial. And by depressed, that means it's going to be 1 degree less than what you started with. We started with a quadratic. So this 1 is going to be the coefficient on x to the 1 because you come down a power, and then you have plus 3. That is actually your answer without any remainder. And if you think about it, what we really did, x squared minus 5x minus 24, we took this, x squared minus 5x minus 24, we divided it by x minus 8, and we got this answer because in reality, again, if I cross multiply, we could have just factored our initial product. But I was showing how you would get the same answer by doing your synthetic division. All right, let's try one more example. Actually, I might even do 2 more examples. So here we have x plus 4, and then we have ourselves a cubic polynomial. So I'm going to pick off my r. Remember, this is x minus a negative 4. So negative 4 is going to go in the box, and then I write out my coefficients. So 3 is the coefficient on x cubed. Then the next power is a 10. Notice I do not have a power of x, so I'm going to put a 0 there, and then a negative 22. I draw my line, put a little plus here, and immediately you always bring down that first coefficient. Then we're going to multiply, add, multiply, add. So 3 times negative 4 is a negative 12. Add those together gives me a negative 2. Negative 2 times a negative 4 is a positive 8. Add those together, you get 8. 8 times negative 4 is a negative 32. Add those together, and we get a negative 54. Now this is going to represent my remainder. If you get a 0 there, it means you have no remainder. But this, we actually got a number. So how does this look? We want to write our depressed polynomial. So we started with x cubed and we divided it by x. So my depressed polynomial is 1 degree less. It'll be x squared. So this is going to represent 3x squared minus 2x plus 8 minus 54 over, because that's my remainder, my original divisor, which is x plus 4. And that would be your answer. So this one was not exactly factorable because we had a remainder. If you have a remainder of 0, it means you had a perfect factor. But that is still your answer. What I would like to do off to the side here is the example we did in the previous slide where you were dividing x cubed plus 64 by x plus 4. And just to show you, so we saw how it took several iterations of the dumb monkey sometimes burp. Synthetic is so much faster. So let's see how that would work. So what goes in the box? Is that a plus 4 or negative 4? Hopefully you said a negative 4. Okay, so it's always what would let, it's the root. So it's like setting that denominator equal to 0. Now my coefficients are going to be a 1 for the x cubed, a 0 for x squared, a 0 for x, and then my 64. I draw my line, I bring down my initial coefficient, and I'm going to again multiply, add, multiply, add. So negative 4, add, that's a negative 4. Multiply negative 4 times a negative 4 is 16. Add, that's 16. 16 times a negative 4 is a negative 64, which gives me a remainder of 0. And voila, again, my depressed polynomial will be x squared because I'm going to be 1 power less, so this will be a 1x squared minus 4x plus 16, which if you look back at our other examples, exactly what we got, but we got it a lot faster, cleaner, less space. It's really pretty powerful. Okay, so hopefully you practice with that and get good, because not all cases are good for synthetic, but for what we will be giving you, they'll all work. Okay, so now let's talk about the remainder theorem, because notice sometimes we get a remainder, sometimes we don't. If you are dividing by that x minus r, then what you get at that last place is the remainder, right? So let's take a look at what happens if I just plug a number into my function. So let's see what I get with f of 2. If I just plug in 2, I get 5 times 2 to the 4th plus 2 times 2 cubed minus 20 times 2 minus 6. So let's see what that would give me. I'm actually going to just go to my calculator here and work that out. So this is going to be 16 times 5, which is 80, plus 8 times 2, which is 16, minus 40 minus 6. That gives you an answer of 50. You might be like, okay, well, that was interesting, so what? But look at this, because this is pretty important. So notice I got it, this is my actually going to represent the remainder. It's called synthetic substitution. By just plugging a number in, I know what my remainder will be. Well, how else do we get remainders? It's as if I took x minus 2 and divided it into that polynomial. So 2 goes in the box. My coefficients are 5, 2, I do not have a squared term, negative 20, negative 6. We're going to do it synthetically. So there's a plus here. We bring down the 5. 5 times 2 is 10. Add 12. 12 times 2 is 24. Add 24 times 2 is 48. That's going to give me a 28. 48 minus 20. 28 times 2 is 56. 56 minus 60 is voila. Notice these are the same numbers. So the reason why we care about that is if I want to know whether something is a factor of a polynomial, rather than doing the whole synthetic division, I can just plug what I think the root of that factor is, and if I get a number, it's not a factor. If I get a 0, then I know something is factorable, because you want a remainder of 0. So for instance, in this next example, I'm going to plug in x equals negative 3. So we have negative 3 to the 4th plus 3 times negative 3 cubed minus a negative 3. And be careful with these negatives. Always put them in parentheses, minus 3. So negative 3 to the 4th is going to be a positive 81, because that's a positive exponent. And then we have 3, so negative 3 cubed is negative 27. Negative 27 times 3 is going to be a negative 81. Then minus a negative 3, which is plus 3 minus 3. And voila, this one is, woo, we got 0. We got a remainder of 0. What does that mean? Well, that means that x minus a negative 3 goes in evenly, is a factor of that polynomial. And so if I wanted to, now that I know it is a factor because I got a 0 remainder, now I would go ahead and do my synthetic. So negative 3, let's see, this will be a 1 for the x to the 4th, 3 for the x cubed, there is no x squared, negative 1, negative 3. So I bring down my 1, there's a negative 3, which is 0. That gives me 0. That sum is 0. Negative 3 times 0 is still 0. Add those, I get a negative 1, positive 3. So there's my remainder of 0, but now I know my depressed polynomial. I started with a quartic, so this is x cubed, 0x squared, 0x minus 1. What this means is that x cubed minus 1 times x plus 3, that is how I would factor x to the 4th plus 3x cubed minus x minus 3. That's huge, guys. You just factored a quartic polynomial, which is not an easy thing to do. And synthetic division and synthetic substitution helps you do that very quickly. So you want to plug in a number to see if you get 0. If you get 0, that means you can find the other factors of that polynomial by doing your synthetic division. Otherwise, if you don't get 0 for a remainder, then there's no point continuing. All right? I hope this made sense.